The fields of artificial intelligence and automation are rapidly transforming the landscape of engineering. These powerful technologies are ushering in an era of unprecedented efficiency across various disciplines. They are driving innovation and significantly enhancing problem-solving capabilities for complex challenges. This profound impact extends to nearly every facet of the engineering lifecycle, from initial concept to final deployment. AI and automation are fundamentally altering how engineers approach their work and execute tasks. They are also changing the very nature of the solutions engineers are able to create and implement. This evolution demands a new understanding of integrated systems. Engineers are now empowered to tackle problems previously considered intractable. The integration of these tools allows for more sophisticated analysis and optimized outcomes. This shift represents a paradigm change in engineering methodology. The traditional boundaries of design and development are being redefined. Engineers are moving towards more dynamic, data-driven, and adaptive processes. This transformation is continuous and accelerating. This new era emphasizes intelligent systems that learn and adapt. It promises a future where engineering solutions are not only more efficient but also more resilient and sustainable. The implications for global infrastructure and technology are immense. AI and automation have made a significant impact on design processes within engineering. These advanced tools are revolutionizing how products and systems are conceived and refined. AI-powered tools are now capable of analyzing vast datasets with remarkable speed and accuracy. This enables engineers to process information far beyond human capacity. These systems can identify optimal designs that meet stringent criteria and performance metrics. Their ability to sift through countless variables ensures highly effective solutions. Furthermore, AI can predict performance with exceptional precision, reducing uncertainties in the design phase. This predictive capability is crucial for complex engineering projects. Generative design stands out as a key application of AI in this domain. It represents a revolutionary approach to product development. Engineers input specific design goals, material properties, and operational constraints into the software. This defines the problem space for the AI to explore. The software then automatically generates multiple design options, often thousands, that adhere to the specified parameters. These designs are frequently novel and highly optimized. Remarkably, these AI-generated designs often exceed human creativity and intuition in terms of efficiency and structural integrity. They explore design spaces that human designers might overlook. This process leads directly to the creation of lighter, stronger, and more efficient products. Such advancements are critical in industries like aerospace and automotive. Beyond generative design, AI-enhanced simulation software is also transforming engineering. These tools provide deeper insights into system behavior. They can model complex systems effectively, accounting for numerous interacting variables and environmental factors. This allows for comprehensive virtual testing. Crucially, this software can predict potential failures accurately before any physical prototype is built. This foresight saves significant resources and time. The ability to simulate and predict reduces the need for costly and time-consuming physical prototypes. Iterations can be performed virtually, accelerating development cycles. Ultimately, AI and automation accelerate the overall development process from concept to production. This speed is a competitive advantage in today's fast-paced market. Engineers can explore more design variations and optimize performance with greater confidence. This leads to superior products reaching the market faster. The integration of AI in design and simulation fosters a culture of continuous improvement. It empowers engineers to push the boundaries of what is possible. This technological synergy allows for the creation of highly complex and optimized structures. It ensures that designs are robust, efficient, and innovative. The manufacturing sector is currently undergoing a profound revolution driven by AI and automation. This transformation is reshaping production methodologies globally. Automation, powered by advanced robotics and AI, is streamlining production lines like never before. It creates highly efficient and interconnected manufacturing environments. These technologies significantly increase precision in manufacturing processes, minimizing deviations and errors. This leads to higher quality outputs consistently. The reduction of human error in production is a major benefit, enhancing reliability and safety. Automated systems perform repetitive tasks with unwavering accuracy. Smart factories are at the forefront of this revolution, equipped with an array of sensors and AI-powered analytics. These systems gather vast amounts of operational data. AI algorithms continuously monitor equipment performance, detecting subtle anomalies that indicate potential issues. This proactive monitoring prevents costly breakdowns. They can predict maintenance needs proactively, scheduling interventions before failures occur. This predictive maintenance strategy maximizes uptime and operational efficiency. Furthermore, AI optimizes resource allocation, ensuring materials and energy are used efficiently. This reduces waste and lowers operational costs significantly. The cumulative effect of these advancements leads to a substantial increase in overall productivity. Manufacturing facilities can produce more goods with fewer resources. This also results in reduced waste throughout the production cycle, contributing to more sustainable manufacturing practices. Resource efficiency is a key outcome. Ultimately, the integration of AI and automation leads to improved product quality across the board. Products are more consistent, reliable, and meet higher standards. Engineers in manufacturing are now focused on designing and managing these intelligent systems. Their role shifts towards oversight and strategic optimization. The factory floor becomes a highly integrated and responsive ecosystem. Data-driven decisions guide every aspect of production. This evolution ensures that manufacturing remains competitive and adaptable to market demands. It fosters innovation in production techniques and supply chain management. The future of manufacturing is intelligent, automated, and highly efficient. Engineers are pivotal in designing and implementing these advanced systems.